Translations. So the transformation we're going to focus on this slide has to do with translations. A translation is a transformation which slides or moves in function world we said shifts each point of a figure the same distance and in the same direction. So in this example that we have here, now I'm going to use some highlighters here. So my pre-image is EFGH. It's the one without the tick marks. Remember, there's four representations of the graph. So I start off with, and I have my graph is started with. So the next thing I want to do is I want to set up my table of values. So my table. In a table of values, you have input and you have output. So input, which we call pre-image, and then output, which we call image. So I'm going to start by writing all my original points. So E, F, G, and H. So E is located at 1, 4. F is located at 5, 4. G is located at 5, 2. And H is located at 2, 1. So my image is the ones with the tick marks, E prime, F prime, H prime, and G prime. So now let's write down their locations. So E prime is located at -2, -2. F prime is located at 2, -2. G prime is 2, -4. And H prime is -1, -5. So now I've got my graph, I have my table. So before I come up with my rule, maybe it's important to describe your shift. So it appears that we have gone right and down. So how many units right did we move? Well, if I am starting at 1 and I go to -2, well, it looks like we went, no, sorry, right. Hello, getting my right and my left mixed up. We went left and down, okay? Left, down. So I'm at 1 and then I go to -2. So it appears that we shifted left 3 units. 1, 2, 3. Well, if that's true, all of our points should have shifted left 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So then how many did we shift down? So it appears that we've gone down 1, 2, 3, 4, 5, 6. So if I'm at E was at 4 and went to -2, indeed we went down 6. So let's write that verbal rule. So our movement is left 3, down 6. So how do I write that as an algebraic rule? Well, my original points x, y, my x values appeared to, by going left 3 minus 3, so we're going to subtract 3 from the x. And by going down 6, we're taking 6 away from the y, so we're going to subtract 6 from the y. So take your x value, 1, subtract 3 from that, you'll get your negative 2. Okay? 5 goes in, 2 comes out. 5 goes in, 2 goes out. 2 goes into x, negative 1 comes out. Same goes for the y's. Plug your y values in, 4 goes into y, take 6 away, negative 2 goes out. 2 goes into y, take 6 away, negative 4 goes out. So now we have our 4 representations. We've got our verbal description, our algebraic rule, our table of values, and our graph. So one thing that I want to point out when it comes to translations is whenever you make segments from the original to the image, notice what happens. So if you look at all these segments that I've just drawn, so from E to E prime and F to F prime, G to G prime, H to H prime, notice that those segments never cross. Well, what does that mean when we have segments in the coordinate plane that never intersect? They're parallel to each other. So the segments are all parallel. Your double lines are your symbols that you use for parallel. But also notice not only that, but notice that your segments are also the same length. So what happens, what do we call it when we're the same length? We're congruent to each other. So all of these segments are congruent. So when we create translations, we're shifting the same distance in the same direction, up, down, left, or right. And then our segments that we create from the original to the image is going to be, all those segments are going to be parallel and congruent.